Hello and welcome to this presentation. My name is Dmitry and I'm excited to introduce you with a conceptually new way to build, extract, process, modify and calculate mathematical models online. If you are a data scientist, a mathematician, a statistician, a researcher, a person having a touch upon mathematical modeling this way or another, or just a curious person interested to learn mathematics, data science, statistics, you will find this interface useful. The interface is built using Python Django and provides an SDK to be used as a client app with either your platform or your home page. Having an SDK for Python, Ruby, PHP, and Java will allow to seamlessly integrate it into your online platform or just the home page without actually having to install anything. You might be curious to know why not to just install MATLAB or any other scientific software and start using it. First, you need to purchase a license for MATLAB. Second, you'll need to download and install this software locally, which means it will take you time, effort, resources. Third, there is a steep learning curve. It will take you a while until you familiarize yourself with MATLAB, get used to its syntactic notation, mathematical formulas, and all this internal MATLAB stuff. Also, you will not be able to port your models into your online resource without significant effort from MATLAB. And sixth, finally, many convenient features such as ability to draw an SVG graphics, ability to easily modify, switch between models online, ability to use your own notation or just scan whatever document you have and turning it into a formula just not there. With this new online tool, you will have all this convenience available. So let's start looking at it. Let's create a simple model, in this case an integration model. Let's just draw an integral 3x square dx. Now, in the beginning, we need to convert it into an image before we actually start building our model. We click on convert and here we go. We got a draft of our model. This is already an image which can be processed, can be pattern matched, and can be used for computational needs. So let's click on the gear sign here and here we go. We got our function integrated, it's extracted, we have our variable, and we also got a nice graph on the right which we may zoom in, zoom out, move around. We can also resize if we want it slightly smaller here. Let's make it 150 by 200 and let's imagine we want to create a slightly different function, maybe a little different. We can revert all this by clicking undo. So let's integrate another function. For x cube dx. Notice that we can always fix this, and we can also change the palette color here. Let's choose another color, say green, just for the sake of difference and slightly different appearance. Now when we click on convert, it will be slightly smaller than the original model, but still will be there. You see here. Now we have two models. Only one of them is extracted for now, the first one. So when we click on the gear sign here, we will get the second one easily. Here we go. We got integrated our function, we have our original function there, and we have our variable x. So now we have two models. We can switch between them. We can get from one into another, and this is already a good base for building our mathematical modeling tasks, such as optimization tasks, forecasting, estimations, different types of mathematical tasks such as integrating, solving linear or partial differential equations, or any other mathematical task. All those things we generate here, that's our job queue, and we are able to switch between them or use them in conjunction. We can blend them, we can merge them, we can compose them, and we can use them on their own as well. So let's create a third one. This one will be slightly different. Let's clean some of our stuff here, and let's picture something different. Never mind. If we don't like this, we can always revert by clicking undo and then repaint it. X, the X. Now let's compute this one, and let's change the size slightly here, just to demonstrate that things work the way we want them to. So this will be 240, and this will be 280. And let's change the color from green to blue this time, just so we have different backgrounds. So as in the beginning, we first convert it. Here we go. Now that we have the draft in place, we can actually render it, we can process it and integrate it. So we click on the gear sign here. Here we go. We got our third function, we got the original function, and we got the variable. We actually did the computation here, and we got the nice graph on the right here. So we still can switch between our models here, go back and forth, or we can even delete one of them if we want, this way. Nice. So this interface will give you a powerful tool allowing not to waste your time for figuring out what's the appropriate symbolic notation to use to make your models rendered and extracted, along with powerful computational and graphical utilities which will create your models and let you use them all the way ahead. Also, if you're just curious about learning mathematics, learning statistics, learning calculus, you will find this sort of tool extremely useful because it will save you a lot of time and effort by doing the most tedious and the most basic tasks, such as figuring where to find this symbol or another. You just need to draw it and you're there. That's about it. I hope you enjoyed the presentation. Thanks.